Welcome dear students. We were talking about the electrophilic substitution reactions of the benzene, and in this lecture we are particularly going to discuss about the halogenation of the benzene. Halogenation can be defined as the introduction of halo group to benzene. So introduction of the halo group to the benzene, that is called as the halogenation of the benzene. As you know, the order of reactivity is fluorine is most reactive, then chlorine, bromine, and least reactive is iodine. The fluorination, sometimes it becomes too fast to control, and iodination is very slow due to very less reactivity of the iodine. So that is why whenever we are talking about the halogenation of the benzene, mostly chlorination and bromination is performed. My dear students, for chlorination and bromination, the catalyst used in case of fluorination, that will be ferric chloride, and in case of bromination, that will be ferric bromide. Or simply you can directly use the powdered iron, and when the powdered iron that will be introduced in the reaction mixer, it will react with the chlorine or bromine to form the ferric chloride or ferric bromide. So either directly ferric chloride or ferric bromide is used, or you will just introduce the powdered iron in the reaction mixer. Chlorine and bromine, they will already be there, so they will react together to form the catalyst, that is ferric chloride in case of chlorination and ferric bromide in case of the bromination. Now my dear students, the general reaction should be that benzene reacts with halogen in the presence of ferric halide. My dear students, from one corner of the benzene, the hydrogen will combine with halogen, it will form HX, and this halo group will be introduced to the benzene ring, and that will be changed to the halobenzene. We can also talk about the mechanism of this reaction, and the mechanism will follow same steps as we have already discussed in the general mechanism of the electrophilic substitution reactions of the benzene. In the first step, reagent that reacts with catalyst, and this halogen taking two electrons that will join with FeCl3, or if we are talking about the general mechanism, then that should be FeX3. X positive and FeX4 negative, they are generated. My dear students, this one is the reagent, it is the catalyst. So in the first step, the reagent and catalyst, they react together to form a strong electrophile. Because of the high stability of the benzene, the weak electrophiles, they cannot penetrate the covering sheath of the pi electrons around the benzene ring. So that is why in the first step, the strong electrophile is generated, and this strong electrophile is basically halogenonium ion. You know that the halogen atoms, they have 7 electrons in their valence shell. So in order to complete the valence shell, they only require 1 electron. and instead of giving one electron to the halogen atom, you have removed another electron from the halogen and it is converted to its cation. Now it needs two electrons to complete its valence shell, so its electrophilic character that will be increased and it will act as a very strong electrophile. And similarly, this FeX4, that is the Bronsted base. So the first step is generation of strong electrophile. In the second step, this strong electrophile attacks the pi electrons of the benzene, and my dear students, a carbocation or carbonium ion is generated, and this carbonium ion will be stabilized by the resonance, as we have already discussed in the general mechanism of the electrophilic substitution reactions. So carbonium ion is created, and this carbon, because it is directly bonded to two other carbons, so that is basically a secondary carbocation or secondary carbonium ion, and this positive charge along with these pi bonds, it can move throughout the ring, so it will be stabilized by the resonance. And in the last step, my dear students, now the base produced in the first step, that was FeX4 negative. Now it will take the hydrogen of the benzene, and the bond that was between carbon and hydrogen, it will be shifted inside the ring between two carbon atoms. You will get HX, the catalyst which was used in the first step, that will be regenerated, and my dear students, finally your product, which is a halobenzene, it is formed. So this one is the mechanism which has three steps. The first step is generation of strong electrophile. The second step is the attack of strong electrophile on benzene. And the third step is the regeneration of the catalyst. As you know, the catalyst is not used in the reaction. It should be regenerated at the end of the reaction. Now, my dear students, if you want to discuss some example, that will be very simple. Just this one is benzene, and if chlorination is there, chlorine will react in the presence of FeCl3, and you will get chlorobenzene plus HCl. Similarly, if there will be bromine, then the benzene will react with bromine in the presence of FeBr3, you will get bromobenzene and HBr is produced. So we have talked about the general mechanism in which no halogen is specified, rather X2 means general halogen that is taken. So in this way, the halogenation produces the mono-substituted halo products, and this was all about the halogenation of the benzene. I hope so the lecture will be understandable for you people. In case you find any problem, you can ask in the comment section. Till then, take care.